All right, let's see how you did on this question. I can't stress this enough. If you have not tried this question already yourself, stop the video and go try it on your own. I've emailed you a link, or excuse me, I have with an attachment to these questions, so go take a look at it. Even if you can't print it, write it on a sheet of paper. Obviously, this first part will be tough on the slope field, but everything else you should be able to do on a sheet of paper before you watch this video. Okay, consider the differential equation. Ooh, looks awful. Let y equals f of x be the particular solution. Cool. With the initial condition 0, 1. A portion of the slope field is given. Sketch the solution curve through the point 0, 1. I'm going to do this in a fun color so that you can see it. First, we need to find the point 0, 1. And then remember, sketching solution curves is just going with the flow. So we're just going to sort of follow along with these field lines. Be very careful and remember that you need to extend beyond the edges of the actual slope field. It looks a little steeper to me over here, but then maybe it kind of like that. Okay, it looks pretty steep there on that other side. Okay, that's the gist of what you should have drawn. Now, part B says to write an equation for the tangent line and use the equation to approximate f of 0.2. We have seen this only like a million times, right? So we need two things to write the equation of a tangent line. I need a point, which they gave for me. That's very kind. And I need a slope. Well, slope is dy dx. But I want the slope specifically at 0, 1. So my differential equation is 3 minus y cosine of x. So this would be 3 minus 1 cosine of 0. Cosine of 0 is 1. 3 minus 1 is 2. So my slope is 2. So my tangent line is y minus 1 equals 2 times x minus 0. Okay, which is lovely. But don't forget to do the second part of what part B is asking. Approximate f of 0.2. So f at 0.2 would be approximately what I get for y when I plug in 0.2. So that's 2 times 0.2 minus 0 plus 1. Y plus 1, because I had to add that over, right? I wanted to get y by itself. Okay, 1.4. Do you have to get to 1.4? No. Can you leave it just like that? Sure. Part C. By the way, part A was worth 1 point, only 1. Part B is worth 2 points, 1 point for your tangent line and 1 point for your approximation. Part C is worth a whopping 6 points. 6 points for solving this differential equation. That's humongous. So let me write this down one more time. My differential equation dy dx equals 3 minus y cosine of x. This is true for all differential equation free response questions that I've ever seen. They will have a note on the solution guide for graders, 0 out of ever how many points, in this case 0 out of 6, if it's not separated correctly. So the algebra is very important. I'm going to divide by 3 minus y, and I'm going to multiply by dx. Okay, once I get to this point, what should I do? Is it completely separated? I always ask myself that. Yes, well done us. Now I'm going to integrate both sides. Okay, we're going to be real careful here. The antiderivative, you might be tempted to say natural log of 3 minus y, and you're so very close. What else does it need? A minus sign. You're so smart. Why? Why? Because the derivative of natural log of 3 minus y is 1 over blop times the derivative of negative 1. So I need that minus sign to cancel. What's the antiderivative of cosine? Sine. Good. Plus c. Don't forget plus c. All right. You guys know that I am a big fan of plugging in early, so we're going to plug in immediately that initial condition. And so that's negative natural log of 3 minus 1. I don't need the absolute value bars anymore because 3 minus 1 is positive, equals sine of 0 plus c. 3 minus 1 is 2. So this is negative natural log of 2 equals sine of 0 is 0. So where do I go? Oh no, I have no idea. Wait a minute. Yes, I do. Exactly where I put the arrow. So I have negative natural log of 3 minus y equals sine of x minus natural log of 2. Okay, now the last point is going to be solving this for y equals. And the clue that they give you to tell you that you need to solve for y equals is in the question. Find y equals f of x. It doesn't have to be pretty. It just has to be mathematically correct. So let's do some algebra. The first thing I'm going to do is remove that minus sign. When I say remove, I mean divide both sides by -1. So I have natural log of 3 minus y equals positive natural log of 2 and negative sine of x. You with me? All right. Now what? I'm going to e both sides, right? So I have 3 minus y. You don't have to be a hero here. Just keep all of this in the exponent. Okay, now I'm going to talk about for you hero people, cheat, but everybody else, you can just leave it just like that, okay? I don't mean just cheat. I would leave it like that if it were me. So now to get y all the way by itself, I'm going to add the y and subtract the e. So I have y equals 3 minus e to the natural log of 2 minus sine of x. So that gets me a full 9 out of 9 points. Now, here's what I'm talking about for you hero people. So if I was feeling kind of extra here, okay, I can say, hey, I really feel like the e and the natural log of 2 are going to cancel somehow. But I'm not going to be crazy, and I'm going to remember that multiplying with the same base is adding the exponents. So if I want to separate them, I need to separate them as multiplying with the same base. Okay, so this is natural log of 2 plus negative sine of x in the exponent. So if I'm going to separate that, it becomes e to the natural log of 2 times e to the negative sine x. And then from here, that would be 2 e to the negative sine x. And of course, I still have this as 3 minus y. So like I said, if you're feeling extra, you can simplify this as 3 minus 2e to the negative sine x. But I'm going to be real honest with you, there's no bonus points for doing it the way I did it in pink. Okay, you can do it either way, and it's 100% correct. 6 out of 6 points on part C. All right? So check and see how you did. We're going to take our Unit 7 test next week, and you're going to have some free response questions where you're going to have to solve differential equations. So see what you can do.